Have you ever noticed this? All those everyday electronic devices around us, small, convenient, but after a while, their batteries always run out. Your mouse, remote, earbuds, they die right when you need them the most. And when you don't have a spare battery, that frustration hits hard. And it doesn't stop there. Prices keep rising. Everything costs more, including batteries. Don't underestimate something so small. Those tiny batteries cause more trouble than you think. They solve short-term needs, sure, but in the long run, they become a costly and inconvenient problem. But here's the good news. I'm not here just to complain. I'm here in this video to offer you not one, but two effective solutions that can help you deal with this issue in a smarter, long-term way. And I know, for you to truly believe what you're about to see, there's something I need to make clear. No setup, no tricks, no prearranged results. Right now, I'm using a voltage meter to measure these two completely drained AA batteries so you can see the real numbers, the real outcome, right here in real time. You can clearly see it right here on the voltage meter screen. The number being displayed is 0. So what does that tell us? It shows that these two AA batteries are completely drained. There's no voltage left, no power to deliver. In other words, they are fully dead and can no longer be used in any device at all. And just to make sure you can fully trust this, I'm going to mark it right here as clear proof, so you know this result is completely real with no setup involved. The first step, we're going to mix a cup of diluted salt water. The exact ratio isn't that critical. If you're unsure, just eyeball it, the same way I'm doing right here. But there's one important thing to remember. To make sure the salt fully dissolves, the water needs to be slightly warmed before we use it. At this point, you can see that the salt has fully dissolved, and the water has cooled down, leaving it just slightly warm. This temperature is completely safe, so we can place the batteries in now, and let them soak for about 2 to 3 minutes. Keep your eyes on the screen. Right now, the chemical reaction is starting to happen. So now, 3 minutes have passed. You can see the solution has started to change in an unusual way. There are these greenish formations appearing, and honestly, I don't even know exactly what they are. But there's one thing I'm certain about. I believe in this method. And it's that belief that makes me think this experiment is going to work. When you take the batteries out, don't wipe them dry carelessly, and don't put them straight into a device just yet. There's one important step here. Use fine sandpaper to gently clean both battery terminals so the contact surface is cleaner and can conduct electricity more effectively. Before putting these two AA batteries back into their original position, I'm going to measure them again with the voltage meter. No rushing, no guessing. We'll let the numbers on the screen tell the whole story. This number is actually not bad at all. Compared to before, you can clearly see a noticeable improvement. And if we let it soak a bit longer, there's a good chance the power level could increase even more. At the very least, the result right now is heading in the direction I was hoping for. Closing out trick number 1 with a success, many may wonder why, after soaking in diluted salt water, this AA battery seems to come alive with energy again. In reality, the battery isn't recharged. The warm salt water helps clean the terminals, removing oxidation and residue. This allows the remaining energy to flow out more efficiently, so the voltage rises and the battery works again. And now, we'll be moving on to trick number 2. Moving on to trick number 2, we're working with a different type of battery, a small, flat, round one that's widely used. You'll find it in wristwatches, car keys, digital scales, wireless mice, and many compact devices. This battery provides stable voltage and holds power for a long time, but it has one clear weakness. Once the voltage drops slightly, the device shuts off instantly. No warning, no flickering, and because of its size, most people believe that once it's weak, replacement is the only solution. It's very convenient. If you have a cordless drill with a removable battery, we'll use that battery to feed energy back into the small round one. Next, prepare 2 metal rings and a phone cable with both connectors removed. As for the wiring, just follow what you see on the screen. It's straightforward and not difficult to do at all. And there's one thing you can't skip at this step: electrical tape. We only need a short piece to connect one terminal of the coin battery to the matching terminal on the removable battery, using the cable we prepared earlier. Simple, clean, and most importantly, it keeps the connection secure and stable throughout the test. One terminal of the coin battery has already been securely connected to one terminal of the drill's removable battery. For the remaining terminal of the coin battery, we'll quickly tap and release the wire connected to the other terminal of the drill battery. There's a critical warning here. This action must be done very quickly. If you tap too slowly, the wire can overheat and burn almost instantly. Clearly, this method is much faster, taking less than a minute to finish. However, compared to the first trick, this one is harder to perform and requires more care and control. Just like before, we'll check it again with the voltage meter before putting the battery back in. No guessing, the numbers will tell the result. This result is not bad at all. If the first trick felt unreliable, this one is more worth trying. It's fast and convenient, but it does require higher technical skill and careful execution. I've got a thermometer right here in my hand. Now let's put it in and see how it performs in real use. Both of these tricks worked, not because they create anything magical, but because they change how we look at things we usually consider useless. One method is slower and safer, ideal when you have time and want to be careful. The other is fast and convenient, but it requires more skill, focus, and careful execution. No method is truly perfect, but in moments when you're in a hurry, when a battery dies and there's no replacement nearby, these tricks are enough to handle the situation. And the most important takeaway isn't the battery itself, but the way we think, learning to observe, to experiment, and not throw things away too quickly. If this video saves you, even one battery replacement, then for me, it was worth sharing.